instead of clearing the whole calculator, I'm just going to teach you. Now we're going to do the weight of the vehicle and its fuel economy. Weight, fuel economy. Put them in. Stat edit. Lists. Make sure they're both in there. Looks like I have 18 values in each one.
Should we put the X minimum at 2,000? Or should we put the X minimum at?
I can understand.
What should we put the X minimum at?
It doesn't matter. We actually have a graph in front of us here where they put it at 2,500. Now, this is important because this is actually defining our domain and range, isn't it? Isn't this your domain and range for your function? Everybody follow that that's all the X's and all the Y values that make sense in it? That's what we're looking at. Now, we want to be able to do that. So I'm going to go ahead and go from... on my fuel economy, I'm going to go from 0 to 50. And for my weight, I'm going to go to 0 to 10,000. So for my window, for weight, I'm going to start at 0 and go to 10,000. It's not possible to be less than 0, is it? Can't have negative weight. Well, I guess you could. The blimp has negative weight.
1,000 or 10,000?
10,000. And for my fuel economy, I'm going to go from 0 to 50. My girlfriend gets a little better than 50, but I don't. I drive a little faster than she does because of Prius. It's possible. Yeah? Do you understand that you want to have all the possibilities in here? By the way, motorcycles get up to 100 miles per gallon, don't they?
Yeah.
But they're very low weight.
How many gallons can they hold?
What's that?
The motorcycle, how many gallons can they hold?
A motorcycle? It depends. I mean, depends on if you have one of those teardrop tanks or whatever. I don't know, 5 gallons maybe. Okay, we got it? And if I press graph, go to our stat plot and turn it on. Make sure our stat plot's turned on and graph it. Looks okay. Do you guys get the same graph? Okay, because we changed our window. Now, I want you to notice that there's something special about this pattern. If I draw a straight line through this, and no matter where I draw my line, even if I draw it really carefully, do you see that it eventually gets to zero? I have literally driven a 30,000, 40,000 pound truck, a semi, carry 30,000 pounds. Well, it doesn't have 0 miles to the gallon. So do you all see that this is only going to have a limited use if I use a line? And the same thing for the Prius. Doesn't the Prius get 50 miles to the gallon?
Yes.
Well, I don't see it anywhere there. There's a problem here. This is not the best model for this kind of data. But this model will work if I limit my domain. Isn't it pretty accurate if I limit the domain? Y'all see what I mean about a domain? That's what a domain's for. It isn't just all the x's. It's the x's that you can use for the model you're using. That's what a domain is. And the same thing for your range. Your range of values can be in here for the model that I'm using. Now let's go ahead and do our linear model. You guys remember how to do it on your own? Give it a try. We go to, first thing, stack, and then calculate, and then we're going to try linear regression, and we press enter, enter again. Now the nice thing is our diagnostics on, so it can kind of tell us how accurate we are. A little better than our fat calories, and the calories in fat.
Yes.
Not bad, not bad. It's pretty good, actually, as long as we limit our domain. That's the important thing here. You have to understand that your domain has to be limited. Now, isn't that a pain to have to type all that in?
Oh, yeah.
I don't want to do that. I'm going to go to y equals, and how do I do it? Help me out here. Variables. No.
Statistics.
Variables, and then statistics, yeah.
And then go to the
Equations, and the first one, there it is. Nice. And I can graph it. Oh, hey, that looks pretty good. Not bad. As long as my weight is in between these two values, and my fuel economy is somewhere in here, I'm okay. Yeah? Got it? You good to go? All right. Now there is a better one that actually describes this data much better. Can everybody see that this is starting to kind of level out over here? That it's sort of going downhill, but then it actually seems to be kind of cutting up some more here?
Yeah.
That's actually what happens. And the best model for this is what we call exponential. An exponential model will look like this, which will include my Prius at 50 miles to the gallon, and also my motorcycle, which weighs almost nothing, right? And the moped, which does weigh nothing, right? Yeah, it does depend, but here we go. Do you see that you have to include those and that they have to come up on a curve? Because this is only 50 miles to the gallon. The moped's going to get 100 or 200. It's going to go way up there. And to get out here, you know the worst fuel economy that I can think of is my boat. It gets 1 mile to the gallon.
A what?
My boat, it weighs about 30,000 pounds. So it's out here. And it's down here. But it actually gets close to zero, doesn't it? So we're going to use an exponential regression model. Here's how we do it. Everybody go ahead and clear out your y equals. And let's go to stat. Calculate. Now we have linear regression. Do you know what quad regression stands for? Quadratic. What that's going to do is it's going to make a curve that looks like a parabola. And unfortunately, it's going to curve back up, isn't it? You see how that's no good? The fuel economy doesn't start getting better after you get past a certain weight. That's not a good one. You all want to see it real quick? Okay, press enter. Enter again. Now, we can see that the r squared isn't bad. It's 0.86. That's a pretty good variance. And if we graph it, we have to go to y equals again and clear it. And then we have to go to variables and statistics. statistics and equations, and you don't want to type that in, right? Graph it. Hey, it follows it really closely, and then it has that effect of leveling out, but then it goes back up again. That's definitely, this one actually is probably good to here, and maybe even good over here. I've actually extended my domain a little bit, but it's not a good model. The best model of all, if we use our brains, is that exponential model. So let's go to that. Program, stat, calculate. I'm going to go all the way down to what's called EXP regression. Got it? Press, yep, that's exponential regression. Press enter, and enter again. You see how it has an exponent? It has a number times a value to an exponent. Remember how those look? That they have decline, and then they have the decay, and they have the exponential growth. This is exponential decay, isn't it?
Yes.
The bigger the thing gets, the closer it gets to zero. And it gets really close to zero when they get really heavy. The worst thing I've ever heard of is that it gets 1 mile per 5 gallons. The tanks. The big, huge tanks, the big Bradleys and the big tanks in the Army, they don't get 1 mile per gallon, they get 1 mile for every 5 gallons. About 0.2. You see how they're getting down there? But they weigh like 50,000, 100,000 pounds. It's going to work. So let's put it in there. Go to y equals and clear. Don't forget to clear it. Clear out the old one. Variables, statistics, equation. There he is. Graph him. Curve. Hey, that looks better, huh?
Yep.
This is what it's used for. I can now make a prediction based on this curve, what happens when I go to different types. If I go to trace, the whole point to this is to use my data. Now, this is actually tracing my data. See how it's going to the data points? Now, if I use the down arrow, I actually get on the line. Now, I can go out here to some heavier stuff. A Hummer weighs about 10,000 pounds. Let's see how it does. About what? 7 miles a gallon. That's about right for one of those big motorhomes too. Oh, trace. And then you press the down arrow or the up arrow. If I press the up arrow, I get back on the data points. And then if I press the down arrow, I get back on the line. So I made a prediction. That's what math is for. You take data, you analyze it, you create a model, and then you make a prediction based on that model. And you hope that it's accurate. And if you're really smart, you can make them really accurate. You get some really good data out of it.
Does it also depend on what kind of motor it has?
I'm sorry?
Depends on what kind of motor?
Well, yeah. Obviously your motor matters. Like my Mustang weighs the same as my Suzuki. They weigh almost exactly the same amount. And the Mustang only gets like 15, and the Suzuki gets twice the mileage. But it also has 3 times the engine, so it depends. Yeah, the engine matters. And my boat has 2 big engines in it, so it gets way less. It also has to do with the fact that when you go through the water, you guys know what happens? That as you're moving through, it's not like the resistance increases with the square of the speed. You've heard of that?
No.
Okay, when you go through air, you have a certain amount of resistance, right? Well, the resistance increases at the square of the speed. Well, the air resistance is almost negligible. But when you go through water, the resistance really matters. That's why human beings can't swim that fast like dolphins can. Because we have too much resistance. We